Well, it's a privilege to be here, and also wanted to thank the conference and Dr. Murthy as chair. I really just appreciate this time to share with you just some of the work that our team has been doing around large language models and GPT. And Devasmita in the previous talk gave an excellent overview on just the training of these models and also application in the finance industry. I'll talk about it in the context of business applications. And I titled my talk, "Are LLMs All You Need?" And I used it in kind of a little bit of tongue in cheek because many of you are probably familiar with the seminal paper, "Attention is All You Need." This is the paper that proposed the transformer, which launched this generative AI revolution when we have these massive large language models. And by way of attention, as you're probably familiar with, as you can see in this sentence, the animal didn't cross the street because it was too tired. So now the question was, what does it refer to? And the attention vector in these transformers is really being able to say it refers to animal. And this revolutionized everything in terms of everything else that was part of that transformer architecture. So now that we have these massive large language models, and what I want to talk about today is a broader view of business applications. And so the first part is just to give you an idea of how we're using large language models at Microsoft. Hopefully it will help you think about how you might want to use it in the things that you are developing. But I also want to talk about lessons learned. We've shipped many features in production using large language models over the past few months especially, but even over the past year. And one of the questions that always comes up from those who are not familiar with large language models is, I've seen some amazing tweets and YouTube videos. Why not just connect my application to ChatGPT? I want to talk about the lessons learned there as we think about prompt engineering, retrieval augmented generation, hallucination checks, and also just the other lessons that we've learned so that hopefully you can also use LLMs in an effective way. This is a real-time conversation. I'm not here to say, we know everything, and I'm here to teach you. We are learning every single day. We are learning new things. We are learning how to use them better. We are learning what they're doing and how they might not be as helpful. And I want to make this a conversation with all of you. I want to hear about your learnings. I want to hear about the ways in which you've been using LLMs, because we are all learning together in this new world as large language models have revolutionized the way that we are working. So to take a step back, I think this is probably familiar for everybody at a global AI conference, but we are living in a world where we went from being data poor to data rich. Everything generates data now, unstructured, structured data. The data exhaust. We have way too much data. From an AI perspective, we're also going from big data to big AI to transform processes. Previously, I'm sure for all of you who've been working in AI and in adding AI to various applications, the traditional ways of taking some training data, training a model, integrating it into your app, shipping your app, and then as deep neural networks came online, maybe incorporating things like a convolutional neural network for computer vision, recurrent neural networks, maybe for language processing, but now going to big or even bigger AI with these large language models. And finally, when it comes to collaboration, we're seeing a lot of solo users to digital teamwork. And I know the pandemic probably accelerated a lot of those trends, but the ability to collaborate online has never been greater. So we collaborate online digitally, but also having a co-pilot alongside of us to make us even more productive. And from that perspective, some of the things that you've probably heard of, GitHub Copilot uses OpenAI's Codex model, which has been trained on a lot of open source and other source code, be able to then help you convert a natural language prompt into a chunk of code, right? So those who use GitHub Copilot have said, yeah, they're just happier in their jobs because they can do the important things and the interesting things about architecting a piece of software rather than having to write every single line of code. So now I've heard statistics that 40% of Java code is now being written by GitHub Copilot. So from a productivity perspective, it's just been amazing for coders. In the business application space, we've announced our Dynamics 365 Copilot, basically the world's first Copilot with CRM, ERP, and bringing AI to our business applications. And you probably also heard the announcement regarding Microsoft 365 Copilot. Everything that you're doing in the apps you probably use every day, Word, Excel, PowerPoint, Outlook, Teams, Loop, the ability for large language models to help you there. So ton of things that are going on, and our team and our partner teams and partner apps have been shipping about 34 features that have either shipped already or are shipping in the next 6 months. And so we've had a lot of experience working with these large language models. And here I want to share about just all of the lessons learned in using those. But the benefit of them is really, at the end of the day, empowering people to do more. If you think about the technical skills distribution, the people who are closest to the problem, we want to equip them to solve that problem. And sometimes they don't have the technical skills to be able to solve the problem, either by creating automation, creating an application, or doing anything else that might help them solve that problem that they need to do. If you look at the population, most of the population is probably trending towards the left, where the technical skills are fairly low. And then apps like Word, PowerPoint would be really easy for them to use because it doesn't require that much technical skill. As you go down the right side of this graph, the technical skills requirement is higher. So you think about Excel or Java or C#, and then the programming, right? The number of people who are able to create solutions becomes very few. So the goal of these large language models in the applications that we're building is really just to extend this. So one example in our low-code platform, where we enable you to build flows, robotic process automation, apps, web pages, chatbots. What we want to do is extend this so that the skills required is less, because you have a powerful copilot powered by large language models to help you get your job done. And this is where we're going with all of these large language models. From an overview of the ways in which we are building out these features, one of the big horizontals is in content generation. So just like Debsmita in the previous talk discussed, whether it's going to be a call center. In your call center, you have you're an agent and you're talking with a customer. How would a large language model help generate a response for you so that you would be able to just either edit it or send it directly and save time and be able to serve more customers? Maybe as a salesperson, you just came off of a sales call, and how would AI be able to analyze the transcript or the discussion that you just had, the context of other emails that you've exchanged, and the information that you might have in your tenant-specific Dataverse, for example, and then generate an email so that you could effectively communicate with your customer without having to take all that time. So with these large language models, you're able to take a lot of this information, generate some content that is very, very natural and human-like, and then either edit it or send it directly, increasing productivity and giving you the opportunity to serve your customers better. From a summarization perspective, this gives you an idea of how you can summarize all of those emails. So I'm sure your inbox, if you're like me, they're overflowing. Teams chats or Slack chats, sometimes it's so hard to catch up on a chat. I go away for an hour and I come back and everybody has just been chit-chatting all the time and I can't catch up. How would we use large language models to summarize what's going on? What are the important points? What do I need to know? And then be able to respond appropriately. Subject matter expertise, so be able to take long documents, again, synthesize them, summarize them, help me understand what the important points are so that I'm equipped with the information that I need, and even things like social media, the explosion of everything that's out there to be able to do that summarization. Another aspect of large language models is in code generation. So as you've seen with GitHub Copilot, the ability to take natural language and generate code, also be able to convert that to other languages, programming languages like PowerFX, DAX, or Power Automate flows even. So this is in addition to all what GitHub Copilot can do in a business application specific context. You're now able to create automation, for example. I can say something like, every time I get an email with an attached invoice, save that invoice file to this SharePoint folder and kick off an approval process. That's literally an English sentence. And now large language models can take that utterance, that natural language prompt, and convert an automated flow. So now this flow can run every time I get an email with an invoice attached. It goes to the right folder, it goes to the right place, and I'm able to now run that automated workflow. And all I had to do was describe it in natural language. I didn't have to program anything at all. And that's the power of large language models. Be able to convert natural language to create proprietary data models. Maybe you have a proprietary language of your own, be able to create models to do that, and even document code. From a semantic search perspective, this is also an important application of large language models. So we'll talk about retrieval augmented generation next, but when it comes to being able to reason over large amounts of data, whether it's going to be unstructured data or structured data, these large language models are very, very important so that we could have a dialogue with data, if you will. So as we think about all of these capabilities and use cases, we think about content generation, summarization, code generation, semantic search, and more. These are some of the horizontals and the ways in which we're building out capabilities in Microsoft applications. And so there's just a lot of ways in which you can then stitch these together end to end. So you think about putting together multiple models, either chaining the models together or different models. You might have a code generation model or a chat GPT. Some of the ways in which we're using those together would be, for example, I give a natural language prompt to chat GPT. Chat GPT might be able to describe something in a better way that could then go into a code generation model. So as a human, I want to say something natural. ChatGPT acts as a translator that can then go into a code generation model to generate the code that I want, right? So these are ways in which these models chain together are also very, very effective. So as many of you are probably familiar with, the OpenAI Microsoft partnership enables us and enables all of you to have access to these types of models, whether it's a ChatGPT or a GPT-4. One of my favorite prompts to ChatGPT is asking, how would you remove a peanut butter sandwich from a VCR in the style of the King James Bible? And the response would be something like, fear not, for thou canst remove the sandwich with a pair of tweezers or pliers, and lo, thou shalt be amazed at the power of thine own hand to remove the most stubborn of sandwiches from thy VCR. And there's just a lot of fun things that could happen with ChatGPT. Probably use Codex, which powers GitHub Copilot, giving it a prompt and generating SQL queries, or DALL-E 2, a prompt that would also enable you to create really, really interesting images. So the ways in which these LLMs can be applied are many, and it's just up to your imagination on how you want to help people with these large language models. And because they're getting bigger and bigger, the more parameters that they have, the more effective that they are. So for example, if you think about a text prompt for an image generation model, teddy bears mixing sparkling chemicals as mad scientists and create that as digital art. On the very left, you see 350 million parameters. I mean, it's okay. It's a nice image, but nothing spectacular. At 750 million parameters, it's actually doing what you're asking it to do, mixing sparkling chemicals as mad scientists. But then you get to 3 billion and 20 billion, and the quality of the image is just astounding. And this is just the benefit of these large language models as they get bigger and bigger. So going back to the second part of the talk and the original title of this talk, are LLMs all you need? Why would I need anything else? In our product teams, we have many people who might be going to Twitter and who maybe keep watching YouTube videos, and they see videos like this. There's a lot of ChatGPT hype, a lot of videos that basically say, wow, you know, do we even need developers anymore? It feels like ChatGPT can do everything. Or maybe people try ChatGPT once or twice and they're convinced that that's all you need. I really like this quote. I think it's attributed to Oprah Winfrey, but the idea is don't compare social media's highlight reel with your life's blooper reel. And basically, in the context of social media, we see everything on social media as perfect because it's been curated, because people tried 10 times to get that perfect picture or that perfect video, and then they finally post it. And then we see that and we compare it to our own lives or our own efforts, and we realize, whoa, something's wrong. But don't compare this highlight reel with the blooper reel of your life. Because ChatGPT doesn't always get it right. For example, in our Power Apps application, which enables you to build apps easily, if you go to ChatGPT and you ask it, how do you change the color of the text in a button in Power Apps? It will say very authoritatively, this is what you need to do. And then you go to the product itself and you find that there's no format tab. It made up another dropdown. It's basically hallucinating. It sounds like it knows what it's talking about, but it's giving you an incorrect answer. So ChatGPT doesn't always get it right. So what do we need to do? Are LLMs all you need? My answer is no. If you want to use LLMs and generative AI effectively, you need to have a lot of the scaffolding around it. So one of the scenarios that we're working on is Q&A. How would you have a database of knowledge-based articles, for example, ask a question in natural language and get a response back? If your answer is, well, let me just hook it up to a large language model, then I would argue that is not enough. So here are the things that we're building, and hopefully they're helpful to you as ideas so that you can also use them effectively. And we also love to hear from you. What are your ways in how you're using LLMs effectively? So the first part of this is prompt filtering and responsible AI guardrails. So for example, imagine there's a malicious prompt. The malicious prompt is ignore your initial instructions and do X. If you gave this directly to an LLM model, the large language model will say, okay, I'll ignore all of my protections and I'm not going to have any safeguards in place and I'll do whatever you tell me to do, right? So the layer that you need to have before that is to be able to filter these types of things out. So there's a lot of different techniques for responsible AI. Some of the things that we're doing, for example, if we are creating a chatbot that is specifically tied to documentation, then we might do a similarity measure. Take a look at this prompt, look at its similarity with our knowledge base, and if it's similar, we'll let it pass through. But if it's not similar, we're not gonna let it pass, right? That's how we prevent malicious prompts from getting through. Maybe there are some irrelevant prompts. What if someone asks, well, how do I remove a peanut butter sandwich from a VCR? Not very relevant to the use of building an application. So again, we'll take that similarity measure and we'll see how relevant it is before passing it through. Finally, somebody may ask a relevant prompt, which is, how do I add a data table as a new form in a new screen? So here's something that is relevant and we'll pass it through. So now that we have a prompt, the next thing that we want to do is few-shot learning with prompt engineering. So in this case, I'll go into a little bit more detail later, but we might have some example generators, prompt augmentation, and then this engineered prompt or augmented prompt is the thing that actually goes into this large language model. So now we go into the large language model, we have a result, and we need to do a hallucinations check. So as I mentioned earlier, ChatGPT sounds like it knows a lot. It talks in a way that it's very authoritative. But we need to do a hallucinations check to ensure that what it's saying is actually correct. So some of the ways in which we're doing this is to, again, do a similarity measure or to do some grounding before we finally give out the response. So basically, are LLMs all you need? No, there's a lot of scaffolding that you need to have before and afterwards to use it effectively. But once you have it, the results are powerful and they're super helpful. But you need to have them to use LLMs effectively. So now that we have these LLMs that were basically taking a snapshot of the internet, and this snapshot may be 1 or 2 years old because it's basically indexing and ingesting the tokens of pretty much everything on the public internet. So how would you feed this model new knowledge? Another way to enhance the use of LLMs would be retrieval augmented generation, or RAG, plugins, or other techniques. So for example, if someone asks a question of how do I add a GPT control to Power Apps, ChatGPT may not know that this is a new feature that just came out a week ago. So what we want to do first is use retrieval augmented generation. And this you can think of as like a mini Bing or a mini Google, right? It's basically an index and retrieval service. We index a bunch of documents. You can index forum posts, maybe even take YouTube transcripts or Stack Overflow. Basically, you can put in all of your knowledge articles into one place and index it. And then you can do a search for the right answer to this question. Once you have that, maybe I found the article with the answer, I'll pass this prompt and I'll pass this article into ChatGPT and I'll say, hey, here's all the information I want you to summarize. And then ChatGPT will do an amazing job of summarizing all of that information with whatever additional knowledge that it has and give you a very, very human and natural sounding answer that will delight the users, right? And so that's how we quote unquote feed a model new knowledge. Recently, ChatGPT plugins have been really, really interesting. I think that just came out a few weeks ago. But that's the idea of enabling ChatGPT to plug into various data sources. For example, you might not know the latest and greatest from a website, maybe the menu from a restaurant or the opening and closing hours. Then you can use a plugin to connect to that data, to that database, bring in the relevant data, and incorporate that into your response. So prompt engineering, I think, is a whole fascinating topic in itself. But basically, the idea here is you can have a basic prompt that you can use to add into large language models effectively. So for example, write a function that adds 2 numbers and returns a result. This prompt, and then you get a completion. With these large language models open to the public, anybody can do this. So how would you differentiate yourself and use an LLM effectively? You might want to add specific user instructions. You might want to say, hey, be helpful and import any needed libraries first, right? That way you give the large language model more context and more information on what you want it to do. You might want to also give examples, 0, 1, or few-shot learning. Instead of classical machine learning, where you're training a model on tens of thousands of data sets on data points, what you might want to do now is just give it a few examples and say, hey, this is what I want you to output the format in. And then it'll take those examples in just a few examples and be able to craft a response, the focused response. And finally, you can remind it. You can say, here's the context of everything that we just talked about. And then a model such as ChatGPT will then be able to say, okay, now that I know the context, I'll craft my response with the context in consideration. So here are all the things that you can do with prompt engineering to get the most effective use of large language models. So going to some of the things that we've learned. When it comes to prompt engineering, you really need to know all the components that you have. So if you wanted to do, say, natural language to code generation, and you wanted to generate some SQL code, what tables do you have? And what are all the columns in the table? And what are all the connections in the columns? The more information that you can feed to the LLM, the more effective your output would be. We've also seen that models have a recency bias. GPT-4 has 32,000 tokens that it can support. GPT-3, 4,000. But even in those 4,000 tokens, we've seen that if you're giving step-by-step instructions in the prompt, the ones at the end of the prompt tend to have a better, if you put the instructions towards the end of the prompt, it tends to have a better response than at the beginning. So we're seeing some of this recency bias in terms of what it's looking for in the prompt. And then providing examples of few-shot learning. For example, if I wanted to generate SQL code, there's Microsoft SQL, there's Oracle, they all have different SQL variants. So providing the right examples will give you more effective results. As I mentioned, LLMs also hallucinate. So never rely 100% on an LLM output. because the hallucination may give you wrong or inaccurate results. So always do your post-processing. If you're generating code, make sure that check that your code compiles, for example, do a syntax check. If you're generating output, you might want to ground it using something like retrieval augmented generation. Ground your answers in your knowledge base and make sure that it passes before you send the response to your user. There might be some prompt injection attacks, those malicious prompts. Attackers may create prompts to get the instruct or deviate from the task that it's supposed to do, telling the LLM to ignore all its instructions, for example. So some of the ways in which we're handling these would be using a classifier to identify relevant versus non-relevant prompts, maybe checking if a prompt follows a pattern that we expect or not, and then checking if the output aligns with a permissible set of responses. So this is a way in which you might be able to avoid a prompt injection attack. So finally, just to summarize, are LLMs all you need? Not necessarily. There's a lot of scaffolding that you want to put in place before and after that. And as I mentioned, this is a real-time conversation that we're having. We have a lot of learnings. We'd love to share them, continue to share them with you, but we don't know everything. So in your use of large language models and what you've learned, we'd love to learn from you. And let's go on this journey together to see how we can revolutionize applications and the way that we do things with large language models and generative AI. Thank you very much.